Okay, now let's move on to the maximum and the minimum. If you look at the formula, y equals ax squared plus bx plus c, or in the vertex form, we still have that a. Every parabola has a maximum or a minimum point. And the thing that determines whether it's going to have a maximum or a minimum is what a is. If a is positive, the graph is going to open up. Okay, so if the parabola opens up, that means it's going to be like this. And if it's opening up like that, then this point down here at the vertex is going to be called a minimum. For example, 2x squared minus 4x minus 1. Let's go ahead and make a table so that way we can graph this. Let's put some negative numbers. 0, 1, 2. 2 times negative 2 squared minus 4 times negative 2 minus 1. That's going to be 2 times 4 to make 8 plus 8 minus 1. That's 15. 2 times negative 1 squared minus 4 times negative 1 minus 1. This is going to equal 2 plus 4 minus 1 equals 5. 0 is easy because it's going to be 0 plus 0 minus 1 equals negative 1. And 1 is also easy, so that's 2 minus 4 minus 1 equals negative 3. Looks like we still don't have anything repeating yet, so we don't know where this axis of symmetry is. But hopefully this 2 will give it to us. 2 times 2 squared. 2 times 2 squared is 8. Minus 4 times 2 is 8. Minus 1. These cancel out. Leaves you with negative 1. And here we finally have some numbers that are repeating, which means that this is probably the vertex. We have 1, negative 3. 2, negative 1. 0, negative 1. Oh, I put that one in the wrong spot. Negative 1 and negative 1. Negative 1, 5. And I think that's going to be it. So after graphing it, you can go ahead and see, yeah, this is opening upwards, and yeah, that's a minimum. And if you're going to label it, the vertex is at 1, negative 3. If a is negative, it opens down, and it's called a maximum. If it's opening downwards, it's going to be this shape, and the maximum is going to be at the top. We have negative 2x squared minus 8x minus 10. Let's make a table for that one. Negative 2x squared minus 8x minus 10. Negative 2, negative 1, 0, 1, 2. Negative 2 times negative 2 squared. Negative 2 squared is going to become a 4 minus 8 times negative 2, which is going to make a 16, but I'll save that step for later, minus 10. So I have negative 8 plus 16 minus 10 equals, if I combine those two negatives, that's a negative 18, so it's a negative 2 in total. Negative 2 times 1, because negative 1 squared is 1, minus 8 times negative 1 minus 10 equals negative 2 plus 8 minus 10. If I combine those negatives, it'll make a negative 12 plus 8 makes a negative 4. 0 plus 0 minus 10 equals negative 10. If I plugged in a 1, that's going to be a negative 2 minus 8 minus 10 makes negative 20. Negative 2 times 4 is a negative 8. Negative 8 times 2 is a minus 16, minus 10. These are all negative, so they're all going to add together to make a huge negative, well, a decent sized negative of negative 34. Did the axis of symmetry even show up in there? No, nothing ever repeated. Let me use a calculator to see if I made a mistake. Okay, so those are all correct, but it looks like the axis of symmetry is going to be more in the negative direction. So let me go back to negative 3, and that would give me negative 4. Negative 4 will give me negative 10. And now I can see that these numbers are starting to repeat because we passed the axis of symmetry. I'm going to make these count by 2's. Negative 3, let me change my color so that you can see it. Negative 4, right there. Then if I go one space to the left, I'm at negative 4, negative 10, which is down here. If I go one space to the right, I'm at 0. Nope. The vertex is going to be at negative 2, negative 2. And then negative 1, negative 4 right here, and then right here. See, so even if you kind of make the wrong picture in your head, as long as you check yourself with the calculator and you make sure that your table makes sense, if you follow the ordered pairs and put them where you said that they belong, it's going to work out. The maximum or minimum point is always at the vertex. All right. Okay, so let's do an example. Number 2. Does this have a maximum or minimum? It's opening upwards. The vertex is down here, so that's going to be called a minimum. It's opening upwards, so A is positive. The vertex shows you where the axis of symmetry is at, and this is at 1, 2, 3. X equals 3. The vertex is at 3, negative 2. And the zeros are the x-intercepts. The zeros are the x-intercepts. So if we look, there's one right here and one right here. One of them is at 2, the other one is at 4. X equals 2, x equals 4, or 2, 0, 4, 0. Okay, so I won't do this one for you, but I'll just read it out with you. This one's opening upwards. That means it has a minimum. If you look here and here and here, those are the points you're going to need to write down for the vertex and for the solutions. Okay. So that's another thing, is that solutions are the same thing as the x-intercept, just like zeros are the same thing as roots. So these 4 words, all mean the same thing. Roots, zeros, x-intercept, solutions. It's all trying to find when is the graph touching the x-axis. The final thing that I have to show you is just that sometimes you will need to label the axis of symmetry, the line of symmetry. Another word for vertex is a symmetric point. A symmetric point is the same thing as the vertex. So if it asks you to draw the line of symmetry, you're just going to find the max, put a dotted line going through that point vertically. that point for the symmetric point or the vertex for this graph is at 2 for y. Well, actually, it's a little bit above. So like 2.2 for y. And the x looks like it's at a half. Okay, now you should be able to do everything on this page.